So how do you find the determinant of a 3 by 3 matrix? So if you're not sure how to find the determinant, you need to go check out some other videos on how to do that. But in this case, I'm going to give you just a couple examples of a 3 by 3, which is a little more difficult than the 2 by 2. So the first step is you just pick a row or a column. And I'm going to pick the top row. Doesn't matter which one you pick. So we're going to use that 1, 2, 3. And so what you do is as you go across the top row, first off you got to know which there's going to be some signs to change as you go across. And it depends on the row number and the column number. So like this first one, maybe I'll just use a laser here. So this first one here is row 1, column 1. Well, 1 plus 1 is 2, that's even. This one here is row 1, column 2. Well, 1 plus 2 is odd, so because that's 3. So that particular one is going to be negative. And this is row 1, column 3, which 3 plus 1 is 4 is even, so it stays the same. So the determinant going across here would be 1 times the 2 by 2 determinant if you were to cross those out. So we'll go ahead, I'll pick a different color here. So if you crossed that row out and that column out, 3, 4, 2, negative 2 is your determinant. And then your next one, we'll do in blue, is the 2, which since it's an odd row and an even column, which gives you an odd number, we're going to change the sign of that one or multiply it by negative 1. And so we have negative 2 times, well, you cross out that row and that column and you're left with negative 1, 4, 5, and negative 2. And then the last one is 3, so plus 3. And you cross out, and we'll go back to red, that column and that row. And we're left with the 2 by 2 determinant of negative 1, 3, 5, and 2. And now you go ahead and just figure those determinants. So this left side would be 1 times negative 6 minus 8 minus 2 times 1 minus 20 plus 3 times negative 2 minus 15. And so you'd have negative 14 minus 2 times negative 19 plus 3 times negative 17. So we'd have negative 14 and then plus 38 and then minus the 3 times negative 17, so it's positive 3 times negative 17, which looks like 51. And then combine those together. And so you'd have negative 14 plus 38 minus 51, which would be a negative 27. And so that's the determinant of that 3 by 3. Okay, so how about example number 2 here? So we got 5, 1, 2, 3, 4, 1, 7, negative 2, 3. So we picked top row before. Let's pick the third column. Doesn't matter which way you go. Now, what you do want to do is go through and find out along here which is positive and which is negative. So this number 2 here, that's row 1, column 3. 1 plus 3 is 4. That's even. That's okay. This one here, this 1, that's row 2, column 3. Well, 2 plus 3 is 5, so that's odd. So that's going to be a negative 1 instead of a positive 1. And this last one is row 3, column 3, which is 6, so that's even, so it stays the same. So our determinant then becomes 2 times the determinant, the 2 by 2 determinant of 3, 4, 7, negative 2. Okay. Then negative 1 times the determinant of 5, 1, 7, negative 2. And then plus 3 times the determinant of 5, 1, 3, 4. And now it's a matter of solving those. So in this particular one, it'd be 2 times negative 6 minus 28 minus 1 times negative 10 minus 7 plus 3 times 20 minus 3. And then again, it's just a matter of simplifying that. Oops. So we have 2 times negative 34 minus negative 17 plus 3 times 17. So we have negative 68 plus 17 plus 3 times 17, or looks like 3 for 51. And so then you can combine those three. And so you'd have 51 plus 17 is 68 and negative 68. So we've got negative 68 plus 68, which would be 0. So the determinant of that 3 by 3 matrix is 0. Now there's a really good chance that I've made a mistake in this, but it gives you the gist of how to do it. And if I did make a mistake, I challenge you to find it. So I'm not double checking these to see if they're right or wrong. So best of luck. Hope this helps, and see you next time.